Good morning, students. Are you all fine? So, in software engineering and testing, we were learning about software design. So, we learned about the characteristics of a good software design. The design process is usually carried out to convert the SRS document into a design document. So, for converting the requirements into a design model, we usually decompose the whole process, the whole functionality into different modules, and we design the modules, and the outcome of a design process will be a DFD, a data flow diagram. So, this is carried out using the SASD methodology. In SASD methodology, as we know, it involves carrying out two distinct activities: structured analysis and structured design. During the structured design analysis, first one is the structured analysis. During this, the SRS document is transformed into a DFD, data flow diagram. So, structured analysis is carried out to convert SRS document into a data flow diagram. In data flow diagram, the data flow diagram means it represents the flow of data between different modules. During the next process, that is the structured design, the DFD model is transformed into a structured chart. So, the purpose of structured analysis is to capture the detailed structure of the system, that is as it is perceived by the user, and the purpose of structured design is to define the structure of the solution that is suitable for implementation in some programming language. So, as we have learned in the last class, a good software design should be correct, it should be understandable, it should be efficient and easy to maintain. It must be easily maintainable. So, with this, we continue with our software design. We had an overview of the SASD methodology. Now, our point is how to develop the data flow diagram model of a system. That is our structured analysis. In this structured analysis, we convert an SRS document into a DFD model, and this is what we are going to learn in this session, developing the DFD model of a system. That is how to develop the data flow diagram model of a system. So, we know a data flow diagram model, it is used to graphically represent how each input data is transformed into its corresponding output data through a hierarchy of DFDs. So, a DFD model is not a single one, it represents a hierarchy of flow diagrams. So, it is a graphical representation that is used to represent how the input data is converted into an output data, how the input data is transformed into its corresponding output, and this is the whole representation is done using a hierarchy of data flow diagrams. It is not a single one. So, the data flow diagram model of a problem consists of many DFDs. It contains many DFDs, not a single one, but the entire process contains only a single data dictionary. We know the data dictionary contains all the data items and the definitions of all the data items. So, for the development of a whole software process, the whole functionality would be stored, the data items and the definitions of the data items will be stored in a single data dictionary. But the representation, the graphical representation of these data items and the flow of data items as well as the flow of data from different modules are represented using a hierarchy of data flow diagrams. For a single software development, there will be a hierarchy of data flow diagrams, but for a software development process, there will be a single data dictionary to store the data items as well as the definitions of the data items. So, as we said, the DFD model of a system is constructed by using a hierarchy of DFDs. The top level DFD is called the level 0 DFD. It can also be called as the context diagram. The first level, that is the top level data flow diagram. As we said, it contains a hierarchy of data flow diagrams, and at the top level DFD is called the level 0 DFD, or it can be also called as a context diagram. It represents the main functionalities of the software. So, it can be considered as an abstract representation of the system. It is the highest level, it is more simplest, and it is the most abstract representation of the system. So, this top level DFD, that is called as level 0 DFD, is the most abstract representation of the system. It is the simplest representation of the system, and it is considered to be the highest level, that is the level 0 DFD. It is the context diagram, that is the level 0 DFD is easy to draw and it is easy to understand too. And below the context diagram, at each successive lower level DFDs, more and more details are gradually introduced. To develop a higher level DFD model, processes are decomposed into their subprocess, and the data flow among these subprocesses are identified. So, for forming the data flow diagram of a software development process, the whole process done is to identify the important functionalities. The main functionalities, that is the higher level functionalities, will be represented using a single level, that is the context diagram. So, the context diagram represents the main functionalities, higher functionalities of the software. It is represented by a single bubble, but below that, the successive lower levels of the DFDs represent more simpler or the sub-process of the higher functionalities. So, the process are decomposed into the sub-process, and the data flow among these sub-processes are identified for forming the data flow diagram. This is what we are going to do on the data flow diagram. Decomposition of the processes. Identify the main functionality, and this main functionality is represented as a context diagram, that is the level 0 DFD. Then decomposition of different sub-processes, and these sub-processes are represented using the next level, successive lower levels of the DFDs. To develop the data flow model of a system, first the most abstract representation, that is the highest level of the problem, is to be found out, identified, and subsequently the lower level DFDs are developed. So, level 0 and level 1 consist of only one DFD each. Level 0 and level 1 contains only one DFD each. Level 2 may contain up to 5 to 7 separate DFDs. Level 0 contains only one DFD, that is the most abstract, simple, and a higher level of representation. It contains only one bubble to represent the whole functionalities of the software, and the successive levels may have 5 to 7 DFDs, separate DFDs, and level 3 up to 49 DFDs, and so on. At most level 4 is possible for is needed. Level 4, at most level 4 will be needed for specifying any softwares. But there is only a single data dictionary for the entire DFD model. The DFDs, it can contain many hierarchies of DFDs depending upon the software requirements of the software. The DFDs may vary, but in any case only a single data dictionary will be there for representing the entire DFD model. And all the data names appearing in all the DFDs will be entered into the data dictionary, and so the data dictionary contains the definitions of all the data items that are used in the DFDs. So as we said, the first level, that is a level 0 DFD, is the context diagram. It is represented by a single bubble. It is the most abstract. The context diagram is the most abstract, highest level data flow representation of a system. It is represented, it is used to represent the entire system, the entire functioning of the software. So it represents the entire system as a single bubble. The bubble in the context diagram can be named with the name of the software system itself. For example, it can be named for a software developed to automate the bookkeeping activities of a supermarket. The context diagram for that software can be named as it is, as supermarket software. So the context diagram can be usually named by the name of the software itself, name of that application itself, because it represents the whole functionality of a software. It can be named as the software itself. That is the noun. The bubble in the context diagram can be named as the name of the software system being developed. That is usually a noun, that is the name of the software. This is the only bubble in a DFD model where the noun is used for forming the bubble. For the other successive DFDs, we use the functions to represent, functions to for naming that successive DFDs. The only DFD having the name of the application or the software is the context diagram. For other DFDs, for other successive DFDs, are all named using the functions that is being processed, that is being carried out by that DFD. All other DFDs are named using the functions of the software. Only the context diagram will be named using the software, name of the software itself. The context diagram establishes the context in which the system operates. That is, who are the users, what data do they input to the system, and what data they received by the system. These are all represented by the context diagram. So it establishes the context under which the system operates. So it represents the external entities, all the external factors who interact with the system, and the specific data items they would be supplying to the system, and the data items they would be receiving from the system. It represents the context diagram should represent all the external entities that interact with the system, and the data items, the external factors supplied to the system, and the data items that the external factors receive from the system. These all should be mentioned on the data flow diagram. The various external entities with which the system interacts and the data flow occurring between the system and the external entities are to be represented using the data flow diagram, using this context diagram. So this context diagram represents the context under which the system operates. That is, it should represent graphically all the external entities that interact with the system, all the data items that are supplied to the system from an external factor, and all the data items that is received by an external factor from the system. These all should be represented graphically in the DFD, in the context diagram. And the context diagram is formed by analyzing the SRS document to identify the different types of users. So it should analyze the SRS document so that it can identify different types of users who would be using the system and the kinds of the data they would be inputting to the system and the data they would be receiving from the system. So these all should be mentioned on the context diagram. So to form a context diagram, we have to first analyze the SRS document so that we could identify the different types of users of the system and what kinds of data they are supplying to the system and what kinds of data they are retrieving from the system. It includes the term users of the system. That means all the users who would be using that system should be identified before forming a context diagram. So this is the first diagram, first level of data flow diagram, that is the context diagram. For forming the context diagram, we should analyze the SRS document to identify the kinds of users, the different users and the different kinds of data they are supplying, that is giving as input to the system, and the different output they are expecting from the system. After analyzing all these factors of the SRS document, we form the context diagram. As we said, the context diagram is named with the name of the software or the application itself because it represents the whole functionalities of the software. And next one is the level 1 DFD. An example of the context diagram is given. Level 0 DFD or the context diagram, it contains all the functionalities of the software, and these after forming the context diagram, the overall functionalities could be decomposed to several levels of hierarchy, level 1 DFD, level 2 DFDs, etc. But the context diagram should be represented as a single bubble having all the functionalities, representing all the functionalities of the software, and it is named with the application software itself. It can have, as a figure represents, it can have a whole process of software development could be represented using a level of different levels of hierarchies of the DFDs. At most level 4 will be found for any software. It can have a hierarchy of DFDs, but the whole development process is represented using a single data dictionary. It contains only a single data dictionary, as you see in the figure. A single data dictionary is used to represent all the data items. It is used to store all the data items used in the DFDs, and also it contains all the definitions of all the data items that is being used in the DFD. But it can have a hierarchy of different levels of DFDs or used to represent the software development process. We have what we have seen is the level 0 DFD or the context diagram. It is usually represented as a single bubble. So the next successive level of the DFD, that is the level 1 DFD. So we learned about the context diagram. Level 0 DFD, it is represented by a single bubble, and in the figure we see the data dictionary. The data dictionary contains all the data items and the definitions of all the data items. The second successive level of the DFD is level 1 DFD. The first level of DFD was the level 0 DFD or the context diagram. We explained that as it is the simplest form, or it represents the highest level of DFD hierarchy. The next successive level is the level 1 DFD. So we shall see the level 1 DFD in detail. So a level 1 DFD, it can contain between 3 to 7 bubbles. Okay, the context diagram, that is the level 0 diagram, can have at most one, that is it could have exactly a single bubble, but the level 1 DFD, usually contains 3 to 7 bubbles. In this example, we represent level 1 as a single bubble. Level 1 DFD is represented as a single bubble. It may vary according to the context of the software. Depending upon different softwares, the number of bubbles may also vary. So level 1 can have at most 7 bubbles. Level 1 DFD is usually contains between 3 to 7 bubbles. Thus the system is represented as performing 3 to 7 important functions. So the most important 3 to 7 functions are represented using the level 1 DFD. So to develop the level 1 DFD, examine the high level functional requirements of the SRS document. As we said, the SRS document should be analyzed to form a DFD, and to form the level 1 DFD, the first, that is the high level functional requirements of the SRS document should be analyzed. If there are 3 to 7 high level functional requirements in a software, each of these can be directly represented as a bubble in the level 1 DFD. So remember, we have to form only at most 7 bubbles in the level 1 DFD. Level 1 DFD can be represented using 7 bubbles. That is, we use level 1 DFD to represent the most high level 7 functionalities that is being used in a software. Examine the input data to these functions and the data output by these functions as documented in the SRS document, and this will be represented in the data flow diagram. So if the system has more than 7 high level requirements identified in the SRS document, some of the related requirements have to be combined. So if a SRS document, while analyzing the SRS document, if we found more than 7 high level requirements in a SRS document, we have to combine some related requirements in the DFDs. So that the DFD must contain at most 7 bubbles. So in case if the SRS document may contain more than 7 high level requirements, some of the related requirements have to be combined. Or if a system has less than 3 high level functional requirements, then some of the high level requirements can be split up into their sub functions, so that we may have 5 to 7 bubbles represented to the system. So for forming the level 1 DFD, if the system may contain more than 7 high level functionalities, then some of the related functionalities, related requirements have to be combined. And if the SRS document, if while analyzing the SRS document, the system may contain less than 3 high level functional requirements, in that case we need to split some sub functions, so that the number of bubbles in the level 1 DFD may roughly be 5 to 7 bubbles. Okay, that is about the level 1 DFD. Next one is the decomposition process. That is, the DFD is actually formed by decomposing different modules or functions. Different functions are decomposed into sub functions. So for decomposition, each bubble in the DFD represents a function performed by the system. Each bubble in the data flow diagram represents only one function, only a single function performed by the system. So the bubbles are decomposed into sub-functions at successive levels of DFD model. The decomposition process is also known as factoring or exploding a bubble, because we are splitting up the bubble so that each bubble represents a single function performed by the system. For example, if a bubble is decomposed to just one bubble or 2 bubbles, then this decomposition becomes trivial or redundant. On the other hand, forming too many bubbles, more than 7 bubbles at any level of DFD makes the DFD model hard to understand. So splitting up into sub-process may be the understandability of the DFD should be considered while splitting the process into sub-process. So the exact level of DFD or the exact level of bubbles of forming DFD is strictly ranging from 5 to 7 bubbles. It is the correct exact level of modeling the DFD. The hierarchy level of the DFD should be at most level 4, and the number of bubbles in each level should be ranging from 5 to 7. If we follow this process, this context, the DFD will be more understandable. If we form various bubbles out of the overall functionalities of the software, the DFD becomes too hard to understand. Or if we form only a single bubble out of the overall functions of the software, the process will be redundant. So there should not be too less number of bubbles or too much number of bubbles in a DFD. So we have to split the overall functionalities of the software in such a way that each bubble represents a single function performed by the system. So that the decomposition of a bubble should be carried out on until a level is reached at which the function of the bubble can be described using a simple algorithm. Okay, each bubble should represent a single function that is to be implemented using a simple algorithm. Now we can now describe how to go developing the DFD model of a system more systematically. So for a systematic development of a DFD model, the first step is the construction of a context diagram. For constructing a context diagram is the level 0 of the DFD hierarchy. It is the foremost simple highest level of the DFD. So for constructing the DFD, context diagram of the DFD, examine the SRS document to determine different high level functions that the system needs to perform. For construction of the context diagram is the foremost level, that is the highest level of the data flow diagram. It is the simpler one and it represents the high level functions of the system. So for the construction of the context diagram, we have to first analyze the SRS document. The SRS document is analyzed to get the different high level functions that the system needs to perform. So we have to first identify the high level functions that the system is expected to perform, and then the data input to every high level function. So first examine the high level functions of the system, then identify the data input, what may be the input to that to perform that high level function. Identify the high level functions, identify the data input to that high level function, and then identify the data output from that high level function. Then next term is to identify the interactions among the identified high level functions. So for constructing the context diagram, first examine the SRS document to identify the high level functions in that system, identify the data input for that high level function, and to identify what may be the data output from that high level functions, and then identify the interactions or the data flow among these identified high level functions. So after identifying all these terms, we form the context diagram, that is the level 0 of the DFD. Then second one is the construction of the level 1 diagram. For constructing the level 1 diagram, first we have to examine the high level functions as described in the SRS document. If there are between 3 and 7 high level requirements in the SRS document, then represent each of these high level functions in a form of a single bubble. If there are more than 7 bubbles, then some of them have to be combined and if there are less than 3 bubbles, then some of them have to be split. So for forming the level 1 diagram, the level 1 diagram of the DFD can range from 3 to 7 bubbles. So first we have to identify or examine the high level functions in the SRS document, and if there are 3 to 7 high level requirements specified in the SRS document, these each functions could be represented by different bubbles on the DFDs. Each function can be represented by a bubble. But if there are more than 7 bubbles or 7 functions in the SRS document, some of the related functions should be compiled, or if there are less than 3 bubbles, some of these have to be split into sub processes, so that in the level 1 DFD we may have the DFDs ranging from 3 to 7 bubbles. At most 7 bubbles are possible in forming the level 1 diagram. Then construction of successive levels, construction of lower level diagrams. For constructing the lower level DFDs, we have to decompose each high level function into its constituent sub functions. Decompose all the functions, high level functions, into sub functions. How would we decompose high level functions into sub functions? See, a set of activities could be done for this. First one, identify the different sub functions of the high level function. The high level functions are formed as the level 1, and we have to identify the different sub functions, that is we have to identify how to split the functions into sub functions of the high level function. Then identify the data input of each of the sub functions. Then identify what may be the data output from each of these sub functions, and identify the interaction. Interaction means the data flow among these sub functions. This is carried out on the successive levels of the DFDs. So first identify the high level functions so that we can split it into different sub functions, and after identifying the different sub functions of the high level functions, the data items needed for that is the input for that sub functions need to be identified. After identifying the data input to the sub functions, data output that is expected from the sub functions need to be identified, and also the interaction among these sub functions, that is the data flow among these different modules, should be identified. And this is represented in a graphical manner in the DFD, in the successive levels of the DFDs. And this step, these all activities are repeated to form the successive levels of the DFDs. In all the successive levels, following levels of DFDs, these activities are carried out repeatedly, so that we can form at most level 4 hierarchy in the data flow diagram representation. Then numbering of bubbles. We know it is necessary to number the different bubbles occurring in the DFD. That means the number helps in identifying any bubble in the DFD. It is easy to identify the bubble or the functions of the bubble from its number. The bubble at the context level usually assign the number 0 to indicate that is the 0 level of the DFD. That means the context diagram of the DFD is identified by numbering this bubble as 0. And each of the successive levels of the DFDs are numbered with, for example, 0.1, 0.2, 0.3, etc. Or again, if it is needed for successive decomposition of the functions or the DFD, each bubble of the DFD can be numbered in successive orders, so that the numbering helps to identify each bubbles or each high level functions and the sub functions in a data flow diagram. Next one is balancing the DFDs. The data flow diagram model of a system usually consists of many DFDs, but the hierarchical level of DFDs should have a balancing among each other. The data that flow into or out of a bubble must match the data flow at next level of the DFD. This is known as the balancing of DFD. For example, we can see the figure. In the figure, it is given that the first in 0.1 there are D1 and D3 represents data flow from the process P1. So P1, that is numbered as 0.1, represents a process or a function, or it is numbered as 0.1, so it is a context diagram level 0. So at the level 0, if we analyze the figure, we can identify that the data flows from this module is D1 and D3. So in this diagram, D1 and D3 are the data flow from the process P1, and from P3, that is 0.3, D2 is the data flow from P3 to P1. This arrow represents the data flow of data from one process to other process. So in P1 there are two data outputs. D1 and D3 are the data outputs from process P1, and D2 is the data input to that process. This is the level 1 DFD representation. When we see the next level, level 2 DFD, the same data flow is represented from process P1, 0.11, the same data flow, that is D21 from P3 process, and the D1 and D2 is the data flow into the process. Okay, the same data flow should be represented, the same manner of data flow should be represented in successive levels of the DFD. This is known as the balancing of DFD. That means the data that flow into the bubble or the data that flow out of the bubble must match the data flow at the next level of DFD also. In each successive levels of the DFDs, the data flow into the bubble and the data flow out from the bubble should match in different levels of DFD. The data flow from represented on the level 1 DFD should match with the data flow in the second level of the DFD. The D1 and D3 of the first level is same as the data flow or represented on the next level, level 2 of the DFDs. So this is how we develop a DFD for a system. So we learned about the different levels of DFDs and how to form a DFD for a system. Now it is simple, and we know DFD is formed using different levels of DFD model or different bubbles, and we learned that up to level 4 DFDs are possible for any, or it is possible and it is needed for graphically representing any software development process. So it is useful to understand the different types of mistakes that could occur while representing a software using the DFD model. As DFD is simple to understand and simple to form, but the only thing is to analyze the SRS document clearly so that we could identify the high level functions and we could understand how to split the high level functions into sub functions. That is the only thing carefully done on forming a DFD of the process. But there may be situations where there can be many different types of mistakes that beginners usually make while constructing the DFD model of the systems. So let's see what are the situations where the beginners may make error in developing the DFD model of a system. Many beginners commit the mistake of drawing more than one bubble in the context diagram. As we learned earlier, context diagram should contain only a single bubble. So, while analyzing the SRS document, we should identify the high level function, that is the at most high level function of that SRS document should be identified, and it should be represented using a single diagram, single bubble. Okay. Next one, many beginners create DFD models in which external entities appearing at all levels of the DFDs. All external entities interacting with the system should be represented only in the context diagram. The context diagram represents the overall functionalities of the software. So, the context diagram represents all the external entities that interact with the system, and it should represent all the data input from external entity to the system and the data output from the system to the external entities. These all factors should be represented in the context diagram, and it should not be depicted at the next level of the DFDs. And next one, it is a common oversight to have either too few or too many bubbles in the DFD. As we have said, there may be a range there must be a range of 3 to 7 bubbles formed on each level of the DFDs. Context diagram is represented by a single bubble, and the next level of hierarchy is level 1, level 2, level 3 and at most to level 4 level of DFD hierarchy. The number of bubbles should range from 3 to 7. At most 7 bubbles should be formed on each successive levels of the DFDs. Forming too few bubbles or forming too many bubbles may cause redundancy, or it may cause reduces the understandability of the problem. So, this also means that each bubble in a DFD should be decomposed to between 3 and 7 bubbles in each successive levels. If we identify more than 7 high level functions, each related function should be combined with each other. Or if there are less than 3 high level functions, some of the high level functions could be decomposed into sub functions, so that we can have 3 to 7 bubbles in each successive levels of the DFD. And many beginners leave the DFDs at the different levels of a DFD model unbalanced. As we said earlier, the data flow from a module and the data input to other module should be same while representing the function in different levels of DFDs. So, the data flow represented in the level 1 should be similar to that of the data flow represented in level 2 and so on. The data flow represented in each level of DFD should be in a similar way. And many beginners make a common mistake while developing a DFD model to attempt to represent control information in a DFD. As we learned earlier, DFD represents only the data flow between different modules. It is used to represent the interaction of different modules, data flow between each different modules, and it does not be used to represent the control information. It is not used to represent the control flow from different modules. The data flow diagram represents only the flow of data between each modules. So, this is a mistake to show control information on a DFD. So, I think it's clear to you. We shall continue with the structured design on the next section. So, learn well. Thank you.